Hi everyone, in this video we're going to solve trigonometric equations. Before we start, we're going nowhere unless we know the previous information. Knowing our special right triangles, knowing SOHCAHTOA, knowing ASTC. Alright, so I'm going to get started. I say we fill this stuff out, and then solving trig equations, it'll be a piece of cake. Okay? Well, let's start with this. I'm going to go in increments of pi over 6, which is 30 degrees. Just to fill out a bunch of angles here that would be rotated from standard position. Alright, 0 radians. This would be 30 degrees pi over 6. And here I go. 2 pi's over 6, which is pi over 3. 3 pi's over 6, which is pi over 2 reduced. 4 pi's over 6, which is 2 pi over 3. 5 pi's over 6. 6 pi's over 6, which is pi. Alright, keep going. 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3, 9 pi over 6 right here, which is 3 pi over 2 reduced, 10 pi over 6, we reduce that to 5 pi over 3, 11 pi over 6, and finally back at 12 pi over 6, or 2 pi. So I can put comma 2 pi. Let's do increments of pi over 4 now. So 45 degrees, right about here. Alright, just going to cut through the middle. And in between these would be 45 degrees, so cut through the middle. Alright, pi over 4, that's 45 degrees. 2 pi's over 4 is pi over 2. 3 pi's over 4. 4 pi's over 4 is pi. 5 pi over 4. 6 pi over 4 is 3 pi over 2, and 7 pi over 4. Alright, that's going to be really helpful knowing this stuff. And might as well just write A, S, T, C for all students take college algebra. Alright, let's do SOHCAHTOA here. Alright, sine of 30 degrees, opposite of our hypotenuse, 1/2. Cosine of 30 degrees, square root of 3 over 2, because it's adjacent of our hypotenuse. Tangent of 30 degrees, 1 over the square root of 3. We could also rationalize that as square root of 3 over 3. Sine of 45, 1 over the square root of 2. Cosine of 45, 1 over the square root of 2. I'm just doing SOHCAHTOA. Tangent of 45, 1 over 1, that's just 1. And sine of pi over 3, the sine of the 60 degrees, opposite over hypotenuse, square root of 3 over 2. Cosine of 60 is the 1 over 2. The adjacent of our hypotenuse, tangent of 60 degrees, square root of 3 over 1. I'll just put square root of 3. Alright, now we know all this stuff. Yeah, solving trig equations can be a piece of cake. I did put some information here about reference angles, because reference angles become very important when we're solving trig equations. I'll refer to the Greek letter alpha as the reference angle, and when that angle theta rotates into the second quadrant, the reference angle is equal to pi minus alpha. Alright? Theta will equal pi minus that reference angle, where theta is the angle. The angle theta will equal pi plus the reference angle when that angle's in quadrant 3. And lastly, when that angle rotates into quadrant 4, theta will equal 2 pi minus the reference angle. Okay? And throughout these problems, we're going to be solving trig equations such as, let's see, our first example, how about cosine of x equals the square root of 3 over 2. And we're going to have to solve this trig equation and find all solutions. Throughout these problems, we're going to let x be theta. Alright? Because this equation has the variable x rather than theta. So, keep that in mind, because you see a bunch of thetas all over the place. And so, throughout this problem, solving these equations, please note that x is theta. X is theta here, x is theta there. Alright. So to start with, we need to find all solutions to cosine of x equal to square root of 3 over 2. Well, let's start out by finding one solution. Alright? We look in this table, we just filled out, and when's cosine taken on square root of 3 over 2? 30 degrees, pi over 6. And we'll write all these answers in radians. Here's one solution. X equal to pi over 6. We need to find all solutions though. So there's one solution. But where else is cosine positive? Quadrant 4. So we'll use a reference angle to figure this out. Alright? What's an angle rotates in the quadrant 4 that has a reference angle of pi over 6? Well, we just take 2 pi and we subtract the reference angle pi over 6. And when you do that, you find this angle 11 pi over 6. Yeah, 2 pi minus pi over 6 is 11 pi over 6. That's another solution. All right. Now we're going to do one more thing. This is it. But one more thing. We need to find all solutions. Can't we find coterminal angles with these? And just rotate them forever and ever and ever? Absolutely. So I'm going to write this as pi over 6 plus 2 times n pi, where n can be any integer. I'll write that down. N is any integer. Same thing here. Plus 2n pi. N can be any integer. Positive or negative. Alright? Because you can just keep rotating, rotating, rotating. And just find coterminal angles. Alright? And remember, because x is the angle. Let's do another one. See? This stuff's not hard at all. We know this. We know this. ASTC. Okay. So here's my second one. How about cosine of x equals negative square root of 3 over 2. Well, see, that's negative. The first thing we have to do is find the reference angle. So let's just hide that negative. 1 is cosine square root of 3 over 2. Alright? Take sine square root of 3 over 2 at pi over 6. But since it's negative, we've got to go over here and figure out when is cosine negative. So when an angle rotates, not this quadrant, but quadrant 2 or quadrant 3, where the S and T are. So, pi over 6 reference angle in this quadrant? Okay, we'd have to take pi minus pi over 6. But that would be right there. See, pi minus pi over 6 is at 5 pi over 6. This is really making our life easy here, isn't it? What's the angle in this quadrant? Oh, there it is. 7 pi over 6. Yeah. 7 pi over 6. That would just be this pi plus the reference angle pi over 6. So please note, when we were working this problem, I had to think, well, the reference angle, alright, is pi over 6. So I can figure out these two solutions here where cosine is actually taking on a negative value. And don't forget, we got to write plus 2n pi, because all coterminal angles are also solutions. Well, recall that the cosine graph, the cosine function, all right, had a period of 2 pi. Huh? That's why we're doing that too. All right, let's do another one. All right, let's do a tangent. How about tangent of x equals square root 3. All right. Well, let's start up by finding one solution. Okay. Some angle in the first quadrant we refer to as x. All right. Where's tangent take on square root of 3? Pi over 3. That's one solution. Where else is tangent positive? Quadrant 3. All right. So what's an angle in standard position rotating quadrant 3 with a reference angle of pi over 3? All right. You bet it'll be this 4 pi over 3. Because it's pi plus pi over 3. The reference angle is pi over 3. 4 pi over 3. Alright? So there's two answers, right? Now, should I do this plus 2n pi plus 2n pi? Well, something's neat about tangent. Remember the tangent function? That its period was only pi? Well, what's the difference between these two angles? Notice it's just pi. 4 pi over 3. Subtract pi over 3. Is 3 pi over 3, which is pi. So it's an easy way to write this answer. We can just say that all answers are pi over 3 plus n pi, where n is any integer. Alright? So I don't have to write this. I'm going to take this out. This takes care of that. Pi over 3, put a 1 in here. You get pi over 3 plus pi, which is 4 pi over 3. You put an error, 2 in there, you get pi over 3 plus 2 pi. Alright? Which is 7 pi over 3. You can do minuses, you can do negative values. So, with the tangent function, we don't have to put plus 2n pi, we can just put plus n pi of this one solution here. Alright? So, that's the answer to tangent x equal to square root of 3. It's pi over 3 plus n pi, where n is any integer. Alright, let's do another one. All right, well, I've been doing x's all the time, and I just did a few in a row with x. I'll go back to a theta. All right, solve this equation. Find all solutions. 5 sine of theta plus 1 equals 3 sine of theta. Whoa, what's going on here? This was different than the last three. First step, we want to isolate sine of theta so we can figure out one of the solutions. All right, so let's subtract 3 sine theta on both sides. All right, I get 2 sine theta plus 1 equals 0. I'll subtract 1 on both sides and then divide that 2. All right. So if I subtract 1 on both sides, I get -1, then I divide that 2 and I get -1/2. So now I have sine of theta isolated. All right, but it's negative. Well, let's just first of all think, where is sine negative? Not here, not here. Quadrants 3 and 4, angles that rotate in the quadrant 3 and 4. So let's start out by finding the reference angle. I'm going to hide that negative sign. Where is sine of theta equal to 1/2? Pi over 6. So the reference angle for this problem, yep, this Greek letter alpha, is pi over 6. So we need an angle from standard position that went into quadrant 3 and quadrant 4 with reference angles of pi over 6. All right, there, 7 pi over 6 and 11 pi over 6. Theta equals 7 pi over 6 and 11 pi over 6. Oh, plus 2n pi plus 2n pi, where n is any integer. So here's our solution. All right. This is quite helpful, absolutely, but if you know this, all right, you find those angles like that. A, S, T, C, and the trig functions. Let's do one more where we need the calculator. All right, last one. This time, in this particular problem, everyone, let's just find all solutions greater than or equal to 0 radians and less than 2 pi. So solve on this interval. From 0 to 2 pi. All right, so it looks like we'll get 2 solutions. We won't put the plus 2n pi or plus n pi like we did with the tangent function. All right, I need you to solve this problem. Sine of x equals 0.8654. Okay, so to begin with, remember, x is like a theta, like an angle. So to find this on a calculator, find one solution. To find that acute angle, that would be in the first quadrant, the reference angle, x equals inverse sine of 0.8654. I have to hit this on a calculator. And also note, in my previous videos when I used a calculator, I always said be in degree mode. We're writing these solutions as radians, all right? So you need to make sure your calculator's in radian mode. Just go to mode, make sure you highlight radian using the arrows, hit enter so it highlights a radian, and you'll be good to go. I already put my calculator in radian mode. So I'm going to type this out. Now to get this up, this inverse sine, I have to hit second sine, and then 0.8654. And write all these answers out to 4 decimal places. So x equals 1.0459. 4 decimal places. All right, that's one solution. In between 0 and 2 pi. That number is between 0 and 2 pi. I was in radian mode. All right, so if you wanted to find the degrees here, everyone, take that number multiplied by 180 over pi, you'll see what the angle is. And it's probably around, probably around 60 degrees or so. Now, we need another solution. Well, this gave a positive value here of sine. Where is sine positive? Quadrant 1, because all trig functions are positive, but also quadrant 2. So we need to find another solution where that angle rotated into quadrant 2 and that angle's in radians. So how do I do that? Okay, here we go. I take pi and I subtract the reference angle. In this problem, this would be the reference angle right here, this 1.0459. Right, it's an acute angle. So on my calculator, I'm going to hit the pi button. I'm going to subtract 1.0459. Well, I can just use the ants button off this calculator. So I'll use the ants button so all the digits are accurate. Here comes the other answer. So I'll put and x equal to pi minus 1.0459. Alright, I'll do this because I use the ants button. And x is equal to 2.0956. So, here are the two solutions. That one and that one. Alright, actually 4 decimal places. These are two, they're in radians. Okay? So keep that in mind. Once again, you're like, I want to see what that is in degrees. Just take that value and multiply 180 over pi. And this angle's around 60 degrees. This angle right there is about close to 120 degrees. Also, last thing. I mean, there's another way to solve this problem. If you actually graph this on your calculator, and we all know the sine curve goes like this. If you just took the graphing calculator and wrote in the equation y equal, remember it gets the high point of 1, but if you typed in y equal to 0.8654, that would just be a straight line that's horizontal, y equal to 0.8654. And you can take your calculator, if you know how to use the intersect button, and just trace to find these points of intersection here. And it will give you the solutions of x. This one, that value right there of x would be this number, and this solution right there, everyone, would be that number right there. Okay? So that's another way to do it. But you need to know how to use the intersect function of the calculator. Alright? That's it.